A lot of customers come to our facility to see displays, and so we're working on building a showroom. I think it relates to this specifically. One of the things we want to have in the showroom is be able to change the ambient light levels for customers so that you can see the products and compare the different products we offer in the type of lighting environment that you might have.
Hello and welcome to the Daktronics Experience Podcast. I'm Justin Oxner here with Matt Anderson. Today we're joined by Shannon Mutschelknaus, Engineering Manager of Daktronics Laboratory Services Group. He's here to talk about image quality and contrast ratios, why contrast is important, how we test for it, and more. And we've got Shannon joining us again today. Shannon, how you doing?
Good. How are you doing, guys?
We're doing pretty good. Matt, are you okay over there?
I'm doing good, Justin. Thank you.
Fantastic. If I don't ask him how he is, he gets crabby.
He forgot to the last time.
And he still hasn't let me forget about it. It's been weeks. So we're going to talk about contrast ratios and image quality and all that kind of stuff that goes into how good an image can look on a display. So can we start with just maybe a definition of what people might think of as contrast ratio and how that plays into image quality?
Yeah, absolutely. Contrast ratio, I think, is a great topic with a lot of confusion out there. So contrast ratio, it starts off really simple. It's the ratio of the light that your display puts out when it's on to when it's off. When it's displaying a black image to when it's displaying a white image. And it's just a ratio of that.
Okay. And I'm kind of curious at the origin of it, just because when we talk about there's a lot of confusion out there. I know I immediately just jump to like seeing it in different ads, and we see it in different spec sheets and requirements.
Right.
But like, where did all this start from?
Mm-hmm. Yeah, I think some of the confusion comes from there being a lot of different types of contrast ratio and different ways to measure it and characterize it, and some of them are really hard to do, and some of them are really easy to do. And so we have a lot of different metrics, and sometimes we just say, oh, it's the contrast ratio, but there's a lot of different kinds of contrast ratio, and we don't necessarily distinguish that well, maybe in spec sheets or when we're talking.
Because I gotta imagine it's how you measure it, like you said, but then also the environment, right? That it's measured in too. So those are what kind of factor in these multiple different ways of doing it?
Yeah, and sometimes displays, the light output's pretty dynamic, and so different things can cause it to actually be different light outputs. So the basic contrast ratio, and what usually you're seeing on spec sheets or when you're buying a TV in the store or a cell phone, is in a particular controlled environment, in a black room and a dark room with no lights, actually below a minimum light level. When you send a black image to the display, and then when you send a white image, you measure the luminance, the light outputs. We call it candelas per meter squared, or nits.
Okay.
It's the measurements of the nits output when it's off to divide by when it's on, or when it's on divided by when it's off.
And sometimes that matters. I mean, you're talking about that's the environment that it's measured in, right? But then I'm not sure I mean to jump ahead, but it's kind of how does that factor into, real life? Because unless you're, maybe a basement living room or something like that where there's no windows and you turn all the lights off, then you might get close to being in the environment that it was actually measured in, right? So how big of a factor does it take when you move it out of that environment?
That's huge. And, we often don't realize that contrast ratio we're seeing on the spec sheet, that's in a dark room. That doesn't have a very great relationship to what you actually observe in normal usage conditions. Like, I think we probably all experience that with our cell phones. We're out, this is South Dakota, we're out pheasant hunting, right? And we get a phone call, we try to answer our phone. Normally, if I was in the town, I'd go walk under a tree for the shade so I can see my screen.
Yeah.
South Dakota, we don't have many trees.
Yep.
So we try to read our phone and, I can't see what my screen says.
Yeah, you're turning away from the sun, so your body gives it the shadow so you can see what's on the screen.
Yeah. You're trying to shade it somehow to keep that sunlight off so you can see it. And that's the contrast ratio. That's actually what we'd call the ambient light contrast ratio, sometimes called ACR.
Okay, so is that type of stuff actually tested for right away too? You said they test it in a black room or a dark, low light level room. Do they test in those bright levels or bright rooms as well?
Yeah, there's definitely test standards out there for measuring that in ambient light and sunlight, daylight, atrium style things. There's different levels of light, and there's a lot of complexity when you have to control the light of your ambient environment because you've got different kinds of light sources at different directions. And that's what makes it really complex and why it's not maybe just on the standard spec sheet, because not just every display manufacturer can do those measurements in that manner. And there's a lot of different ways, and it can be really confusing.
And because there are so many ways, that's why there's no standard way to be able to measure it. So whenever anyone comes up with a ratio like, 10,000 to 1, that could just be how they measured it, and you can't actually compare that to the other manufacturers, right? Because there's no set standard between them.
In the lab, I would say there are standards.
Okay.
But we're not very good at communicating them.
Okay.
Or we're not very good at asking for them when we buy a product. So we go to Walmart or Best Buy, you buy TVs there all the time, and they'll have a contrast ratio, but they didn't say what way that was measured.
Okay.
Yeah, so that's why there's confusion, is you don't know how it's measured and you're just seeing a ratio. So you think this ratio is better than that ratio, but this one was actually tested in a darker room and this was in a lighter room, so this one would actually be better. That can happen?
Yeah, absolutely. Yeah. So, contrast ratio measurement's been a key thing for a long time. And actually in your displays, a lot of folks would say this is actually the most important aspect or property of the display to distinguish your image quality. Because it's the ratio of light to dark. It's what you can see. So you need a good contrast ratio, or you can't distinguish the content, the images.
Oh, yeah. So it's like if you've got somebody wearing a certain colored shirt, say it's a blue shirt on the display, and there's the blue sky background, but they're different shades of blue. Your contrast is going to set those two apart?
Yeah, absolutely. And that's actually even another kind of metric. What I was talking about was just sending a black and a white image.
Right.
You also have color contrast, which is another thing. It's another different type of ratio that isn't usually communicated.
And looking at why this is even important for RA, we sell a lot of billboards and digital displays outdoors, and being able to see what's on those displays is kind of what we might be actually selling.
It's a little important too.
Yeah, if you can't actually see what's there, the clarity of it, especially we've run into it with brand colors, and they want that color to match and things like that. And color matching is a different conversation, but being able to actually see that color come off the display with good contrast in the setting it's in has got to be important.
Yeah, it's really important. For one, it's just like, can you read it? It needs to have enough contrast to read it.
Yep.
But also the size of the contrast ratio affects how fast the viewer can read it. So that's a really big thing with our DOT signage and things like that.
Yeah.
They have to have a really high contrast ratio because you want the human response time when they see that to be fast. You want to know they need to stop. They need to know they need to.
Yeah. Or if they're passing by, they can't just kind of stare at a billboard or any sign on the side of the road too long, or you end up swerving out of your lane or something like that. So it's a safety thing too with how fast they have to interpret the messaging that's on there.
Yeah, absolutely. So it's really important. Contrast ratio has been measured for a long time, and so it's really confusing on our product. So let's maybe start with just the basic one in a dark room.
Okay.
So are you guys old enough to remember CRTs?
Yes.
Yeah.
Oh, okay. Oh, all
Definitely.
right.
I like how nervous you looked before you asked that.
My
but
first
yes.
CRT I took with me to college, so
Yeah. I think my parents still have one at home. Yep.
probably.
Yeah. So CRTs, they can't show a true black. Even when you send a black image to it, they emit some amount of light. And sometimes you maybe witness that at bedtime, you turn it off. There's still a bit of a glow.
Oh, yeah.
And that's kind of the lowest level of black that they can put out. And so it can't get to an absolute zero. And even LCDs are even worse than that. So they have a backlight behind there that's always on. Well, they used to always be on. Now there's more different kinds of backlights, like the LED backlights, that they can dynamically turn those LEDs off and on. And it's just that LCD operates with a light behind it shining through kind of a filter, that the liquid crystal that turns on and off.
Okay.
And so you always have light leakage through that display, even when you send a black image to it.
Light leakage.
That's a new term. We'll have to get that definition on the show notes.
But I'm not sure if this fits into contrast ratio or not, Shannon, but there's also something to be said about reflective, right? Like whenever I thought of a CRT TV, they were very reflective. Even if I had a little bit of light in the room, I mean, it wasn't able to be enough brightness to beat that out, but it was just like you would see the exact like light bulb and everything because it reflected off of it so bad.
Yeah. In that case, the ambient light contrast ratio was not that great.
Okay.
Yeah. So maybe the difference then with the LED product that we're usually selling. LED displays do have a situation where you can send a black image and they actually emit no light, whereas other technologies can't do that. OLED is maybe the closest to LED, where you send a black image, it doesn't output light.
Okay.
And so in reality, our darkroom contrast ratio is, I don't know if it's hard to say as an engineer, it's an infinity to 1. Right? It's infinite because we need to divide by 0. So it's actually, usually we would say it's undefined.
Okay.
You can't actually divide by 0.
Right.
Yeah.
But
I do remember that. Yep.
Yeah. So what you're saying, I mean, again, just to clarify, black is the absence of light.
Right.
Correct. Complete darkness, complete absence of light, and then white would be the abundance of light.
Mm-hmm. Yep.
So on a spectrum, that's why they say in school, like black, gray, white, they're not colors, they're shades, because it's either all or nothing.
Yep. It's the amount of
Oh,
light.
Matt just learned something.
I was just fascinated by hearing you describe that, Justin. But so this, I mean, all this kind of ties into, there's a lot of different things here, but, and I know we keep going back to TVs, but it's, I think, what most people are familiar with.
Yeah.
But I mean, we've heard a lot of these, these crazy ranges of these contrast ratios. And there's even an article I think that we had talked about where it said how TV manufacturers lie to you. So I'm kind of curious. There's something in there about native versus dynamic contrast ratios. I don't know if you can help maybe explain that a little bit.
Yeah, definitely.
Sure, yeah. So
Thank you.
There's
Yeah.
2 categories of that, and even in the darkroom when you're doing that measurement, so not taking into account ambient light, the native contrast ratio is when you send that white image, and it's kind of based on the properties of the display, how much light leaks out during the when you send a black image.
All right.
But there's a lot of other things the display can be doing that changes its luminance, how bright the white is, and it can do that dynamically based on the image. So especially with the LCD product nowadays, we have basically an array of LEDs behind that LCD, and they can turn those on and off so that maybe for HDR, you can have a localized part of that display brighter than the rest of the display. So then you get a dynamic contrast ratio where that changes based on the image and the type of content you send to it. And so then it gets really complex, and you need to know which one you're trying to compare.
Yeah, and that's kind of, there's a couple of streaming services that I use, and one lately just started doing HDR. It was Disney Plus is what we're using.
Okay.
But all of a sudden I started watching back over movies that I've seen for a long time, and I remember some scenes where it was really hard to see, in the background, and now I could, but it was like some of the darker images where you wanted it to be dark was light gray now all of a sudden. So it was one of those, it was a give and take, it seems like, for now, but that's just kind of what, when you're saying HDR and how this affects it, how it's maybe not, it's calling out the brightness a little bit more and won't let it get as dark. But I don't know if it's a trade-off is the right way to say it, but I mean, it looks amazing, but it was just, I think it was like Star Wars was the example, right? When they're just out in space.
Yeah.
And it was like gray and then stars, right? It wasn't as dark as it was getting, but.
Yeah.
I was worried you were going to bring up a Game of Thrones episode again.
I said Disney Plus.
I know. I'm still worried you were going to bring up the Game of Thrones last episode again.
Or Jurassic Park. Didn't we talk about Jurassic Park last week?
Yeah, we talked about
Shannon was
Jurassic
on?
Park too, yeah.
Yep.
We cover a wide range of topics.
So there's a phrase out there that it's the contrast ratio then, and I'm thinking it was in regards to image quality though, is that it's the most important but least understood.
Yeah.
Why is it? Is it because of all these different ways to measure it that maybe people just don't understand?
Yeah, I think it's because there's a lot of different ways to measure it. And I think it's also that there's marketing things out there where people will be trying to confuse customers.
Big numbers means it's better.
Yeah,
is pretty
big
much what you're
numbers
saying.
make it sound better. And so it can get really confusing, but it is really important. And so as a consumer of displays, whether it's cell phone displays, TVs, or our big beautiful displays, it's challenging. Like how do we compare those? I think for us in the lab, we got really expensive equipment. We can actually do the measurements, and we did the measurements, so we know. But as a customer, it's hard. So some of the articles too I've read, it's like, oh, it's hopeless. There's no way to know. But there are ways. All right, so our eyes, because it's really important, our eyes can pick up contrast ratios really easily.
Okay.
So if you see 2 displays side by side, you can tell. the contrast ratios are different.
Like when you're in the electronics section of a store and you see all the TVs on the wall, you can see this one's kind of green, this one's brighter than that one. You can see some of that stuff.
Yeah, yep, absolutely. So, if you look at those displays turned off side by side, you're going to see the blackest black they can produce.
Okay.
In the lighting conditions they're in.
Right.
That's what I've heard sometimes when, when we work, we get involved with different architects, or they're looking at different display types that we had, different millimeter pitches, different pixel layouts.
Yep.
And I know whenever we line ours up side by side, we call it shootout, like to see how good they are, they'll always say, put it on bright white. I want to see how it looks. And it's, all right, now turn it all off. Because everyone has good content. You can have good content playing on all of them, but they know about contrast ratio. And it's always like one of the first things that they say during these like demos is.
So they're doing their own test of white versus dark.
Yep.
Yep. Yeah. And that way you can kind of work around that number. You don't have to focus on just number. You can actually look at and observe the contrast ratio for yourself.
Yeah.
Right. And we've been talking about a whole bunch of different ways to test for contrast ratio. How many ways are out there? I mean, we've talked about like 2 or 3 already.
Yeah. There's a lot of combinations because first you can do the darkroom stuff, and you can send different contests. There's like star screens that you can send to it, and that change with the displays. It can dynamically change their contrast ratio based on content. So there's defined contests with the checkerboard content, star screen content, and all kinds of things in a dark room. But then once you add ambient light, that adds a whole nother level to that.
Yeah.
So some common methods that we use come from the DOT, where they require us to do this to meet compliance and stuff. And we have basically a big spotlight type thing that can put 60,000 lux, which is about like daylight, a sunny day, onto the display and measure the reflection of the light off of that, so you can get some numbers.
Wow.
Yeah, that's crazy. I never thought of like, hey, we're going to bring this big light and just shine it on your display and see if it passes. Yeah.
Because I mentioned a little bit about different LED types, and I don't know. I mean, that's got to factor a little bit into this. When I've looked at some of the stuff, even Daktronics 13 years ago, we used to have a lot of displays, and even before then, that had a lot more LEDs needed to get to a certain brightness level, right? Like sometimes I think our pixels had like 2 reds in it to get brighter. So that was the brightness part, but then there's something to be said about the more LEDs you have on the face of a display, it's probably not as dark as the display can get, right? Because you kind of have like a dark module, dark backing, and then the more LEDs you have on there, there's more chance for reflection, right?
Yeah, especially outdoors when you're in the sunlight. So older displays, we used to have 8, 10, a whole bunch of LEDs per pixel because LEDs weren't very efficient.
Yep.
Going back to the 90s, we had a lot of LEDs per pixel. Now we're down to, for through-hole, we maybe have 3 LEDs per pixel. And so you have a much smaller amount of your display faces the LED. LEDs are not as black as black paint with louvers is that we might put on. And so the smaller those LEDs get, the better our ambient light contrast ratio can become.
So with the contrast, and you were talking about reflection and indoor and ambient light versus outdoor, do we test separately for different applications to say, okay, if you put this type of display outdoors, here's your contrast ratio. If you put it indoors, here's your contrast ratio?
Yeah, what we do is we characterize the reflection factor,
Okay.
which is a metric that we can use then to calculate, if you're in these lighting conditions, we can calculate what your contrast ratio would be.
Okay. Yeah, that's got to be helpful to show somebody if they're looking at that and worried, what's my contrast going to be on this? And if they're trying to swim through the different types of contrast ratios and understand what all that means, that's got to be helpful.
Yeah.
Yeah, because then you also mentioned louvers, though. I mean, that plays a part in it, especially for outdoor displays, right? So being able to put a sense of shade on the display so you can get to those darker levels.
Yeah, that's actually a really cool thing. That's pretty unique to our technology and not something that you'll see on a TV or LCD.
Right. Yep.
Right, so we've got such high ambient light levels. Your average LCD, you can't see that outside. And so not only your black paint can only get so black.
Right.
So there's whole nother level that we go to is adding louvers so that they're not any blacker, but they block some of the light getting to the display face so that the ambient light getting to the display is less, which makes it look blacker to us.
Yeah, because I was kind of getting my questions, aside from the different way you measure it, is between an LCD, I mean, not CRT. We'll go with LCD and LED.
LCD and LED.
Because
there you go.
there's a lot of other differences when you go back to the CRT.
Right.
But it was the fact that we do have actually protruding LEDs that do play a factor. So we do different things like that to help improve the contrast ratio. And then when you get indoor, right, when we start talking about SMD LEDs, that's a whole nother thing because you can actually get those, get the pixel itself down smaller so you can have more of the black paint facing on the module, right?
Yeah, and then even in the LED design, there's differences that we can do. So there's white LEDs and then there's black package LEDs.
Yep.
And the white LEDs, they might get a very high luminance. They could get very bright because they got a really nice reflector, but they can't get as black in the ambient light. And so to get the maximum contrast ratio, actually a black package LED, it doesn't have the same luminance, the same nits on the spec sheet, but it could have a better contrast ratio.
It's kind of that trade-off. You can get like a really bright one that doesn't have as good of like dark shading, or you can have a really dark display, but it can't get as bright. It'll get bright, but just not as high as the white package could.
Yep.
So Matt brought up the difference between LCD and LED, but we've even seen in some cases, I'm going to say houses of worship, where people are using projectors. And how does a projector compare for contrast to LED? Yeah,
projectors have great contrast ratios in a dark room.
Okay.
They look beautiful. But we've probably all been in that conference room or that scenario where, I can't quite read that projector. Like,
and they shut the lights off and then you get sleepy.
Yeah, right. And you fall asleep. And I think that's a cool thing that the NPP product and things, the microLED and all that stuff is really allowing us to replace some of that kind of technology with other things that have much higher contrast ratios. So now we're seeing people that have conference rooms that, hey, I've got a lot of windows. Everyone wants windows. We want to see outside. But now I can't see my screen because I have a projector. You don't have that issue with LED. And that's really one of the big advantages because we have a good ambient light contrast ratio with LED technology.
Matt, go ahead.
I was going to say, it was tying in with what was said earlier in House of Worship, right, about you saying sometimes your eyes are just the best way to see this. So I know there's times where we've told people how different it is versus projection, but then we had like a demo one time where a church had said, hey, I want to see what it looks like next to it. And they had a lot of ambient lighting. The whole back kind of half of the church was all windows. And so they brought it in there. I remember seeing pictures and they brought it in. They couldn't believe it. They had no idea how washed out their content was until they saw it next to an LED display. So
yeah, amazing what happens when you can compare. And thinking of that, like projector versus LED, LEDs are actually emitting light towards the audience, whereas the wall of the projector, the screen of the projector, is what's catching the image, and you're just able to see it. So it's different. It's like the screen's receiving the light from a projector, whereas you're projecting the light from an LED.
Yeah, it's reflecting off the screen.
Yeah.
Good job, Justin. That's very astute.
I said it was accepting it. He said it's reflecting it. So I was halfway there.
What if it's a rear projection one? How does that factor in? I mean, it still can't get as bright, right? But then you need more space behind the screen.
That's transmitting light.
Oh, there you go. It's transmitting.
Is that what you were looking for?
Yep, that's it.
Yeah, and actually, how we measure the contrast ratio for a projector then is way different for CRTs and LCDs.
Okay.
Because if you're a projector manufacturer, you don't make projector screens. And you don't want to measure the light reflecting off the screen because that's not your product.
Yeah, so you have no idea.
Yeah, so then they use a different meter called the lux meter. And instead of measuring the nits, the candelas per meter squared, you measure the lux. So then you measure the amount of light that's hitting the screen, the projector screen, and that's how the contrast ratio is characterized.
Yeah, because you could project it onto a white wall, right? And so the measurement is it essentially until it would get to that screen what it could be at its best, which would just be in a dark room against a dark wall, essentially.
Yeah.
That seems like there would be such a variance in their contrast ratios because it would be largely dependent on whatever the screen is and what the screen's quality is.
Yeah, so that's why it's hard to compare that number that you have on a spec sheet to what the actual performance of the display is in your application.
Right. Do you want to take us back to what we're doing at our corporate offices here, Matt?
Sure. So we talked about sometimes people just need to see what it is like. So we have something exciting that I think that we're working on here back in Brookings, if you want to touch on that a little bit, Shannon.
Yeah. So I think it's really exciting. So a lot of customers come to our facility to see displays. And so we're working on building a showroom. that we can set up the displays and show the different products. And I think it relates to this specifically. One of the things we want to have in the showroom is be able to change the ambient light levels for customers so that you can see the products and compare the different products we offer in the type of lighting environment that you might have.
So changing the ambient light levels, I just pictured like a light switch that slides up to mood
dimmer?
lighting, the dimmer. Yeah. But I'm guessing it'll be a little more sophisticated than that.
Well, I'm going for that simple, but I don't know if we'll actually get
Are we going to
there.
have a spotlight that we can shine on the display to show the difference?
Yeah, it's going to take quite a few spotlights or lights to get. It takes a lot of light to get to sunlight levels.
Okay.
So we'll have at least be able to do the range of things you could see in an atrium or in your conference room that has a lot of windows. We'll be able to reproduce that for sure, and then some level of outdoor lighting as well.
Awesome, yeah, because we always say we want to invite our customers to come visit us here, and it's one of those. I know when they do visit, sometimes we're at the mercy of what the demo area has at the time, because we have a lot of different display technologies that get used at a lot of different demos or trade shows, events, and things. So I think that's another area of this showcase room is to essentially say, hey, here's how we can actually just have a permanent spot to show you this technology, different ambient lighting it might be in no matter what time you would show up.
Yeah, yep, absolutely. So I think I was talking to our sales guys, is like, make sure that customers measure what the light level is at their site and let you know so we can reproduce that in the showroom.
Yeah, I guess the sales guys are getting pretty excited about it as well then.
That made me think of something too, and I'm not sure how this works, Shannon, but if they're going to measuring it right at their site, the older a display gets, right, we say that we've already talked about LED lifetime in the past, about how LEDs slowly can get less bright. How does that affect the contrast ratio then? What, you don't like less bright?
No, it's just kind of the way you said it. They can get less bright.
So darker. I don't want to say darker, but less bright.
There you go.
Yeah, that's a good question. So they do. They lose contrast ratio with age. So half of the contrast ratio is how much light the LEDs put out.
Yep.
And so if they put out less light, you lose contrast ratio. But also we see, especially outdoors, we have dirt and dust that gets on the face of that, and that reduces the blackness of the display. Sometimes that can be washed off. And sometimes it's just a little bit less black of a display.
Seems like a good plug for our services team where they can come out and do display washing for you to get your display nice and clean and keep it with a high contrast ratio.
Yeah. But it just goes back to, I think there's one of the constant themes here is that whatever the spec sheet shows, there's a lot more to that, right? So it's either how do they measure that, in what area, what do they measure it with, the environment, but then also what will it look like in 2 years? Like, okay, that's a contrast ratio and you bought it, but how long is it even going to stay that way? Like, that's not shown typically on what we're asked for either.
Yep.
Right. And you've probably tested a lot of these extra things when it comes to brightness over time. And if you're pushing an LED too hard to reach that certain brightness that you need in that high ambient light application, then you could push your display into other issues beyond just, is it contrast ratio high enough? It could go into other types of display failures even.
Yep.
And you talk about changing, right? So it's the ability to be able to just change a display to dim it down, even if you needed to, but being able to get up to that contrast ratio, because it's, if you're outdoors, you don't want to be dependent on the weather. There was a customer that told me that one time. He said, well, I went with the higher bright option because I don't want to worry about if it's going to be a sunny day or not, right? Because there's some LED stuff that's brighter than others. And so I remember we presented to him, and that's what he said. And that's always stuck in my mind, is just that why wouldn't you have this so it looks good no matter what? And you can dial it down if need be, but you can't all of a sudden dial up past what it's able to get to.
Right, right. You never want to push it past what it's capable of.
Yeah, the contrast ratio changes on the sunlight. And a lot of our billboard customers and DOT customers, most people are seeing the display at rush hour. Well, what's happening at rush hour? The sun is low in the horizon, shining right on the display, or even maybe sometimes right from behind this display, and that's when your contrast ratio, that's when you need it the most.
Yeah. You say sunrise depending on the year and how early you get up, I guess, but it's getting closer to that now.
Right. And we're not all in bigger cities where there's bigger buildings blocking the light to keep contrast ratios looking great.
Yeah, we don't have
trees. We don't have trees either.
Only in town, and then outside of town they go away. Yep.
Well, Shannon, thanks for coming on and sharing some more insight into image quality. Is there any other final points you'd have about this?
I think we covered most everything. Unfortunately, be careful with that spec on the sheet. Make sure that you look at displays side by side and make sure you know what lighting conditions you're planning to use that thing in.
Sounds good. Thank you.
All right. Thanks, Shannon.
Thanks, guys.
Thank you for listening to this episode of the Daktronics Experience Podcast. Please subscribe at your favorite place to listen to podcasts to keep up with our latest episodes.